Well, for those of you who really don't know us, we are a little bit somewhat of the German equivalent to GE. Although we, as global as they are, we make 20% of our business in the US, for example. So we're as much an American company as we are Chinese, for example, and a European. Okay, before we go to the questions of what happens when the virtual and real world collides, let's look at this.
Our world is becoming ever more connected. Billions of intelligent devices and machines generate massive data, bridging real and virtual worlds. Complex data now play a crucial role in the way we move, live, and work, the way we plan and create products and services. Turning the vast amounts of data collected every day into value is a key success factor for companies, economies, and entire societies. We have the domain know-how to transform the big data generated by our systems and products into rich information that enables smart choices. Our data-driven services monitor power plants to guarantee reliable energy supply. Our software and IT solutions teach wind powers how to produce more, and our building management systems teach buildings how to consume less energy. We enable our customers to intelligently automate processes across the entire life cycle of their products. And by simulating real-world objects by means of digital twins, we help them optimize their manufacturing processes. Our intelligent traffic management systems help moving people and goods faster, safer, and with less CO2 emissions. And we develop sophisticated medical imaging systems that help doctors make better decisions faster. We seize the data opportunity to create real value.
All right, this morning we were already agreeing that digitalization is changing our world. So the data volumes are growing into the zettabytes, and the business and market growth from app trading and app selling alone goes into the double-digit billions, and the IT and communications industry is a $4.1 trillion or euro industry. And we can see that the more we drive digitalization, the more it really drives all of our welfare and GDP growth. So what does it mean for an engineering company like Siemens with over 300,000 people in the world that's basically working in engineering for energy, for infrastructure, for industry, for healthcare, and providing the physical goods, the electrical-based goods to drive the necessary applications in this field? Well, still there, big data, analytics, cloud provision of data and systems, mobile and collaboration possibilities, connectivity, the Internet of Things are obviously influencing what we need to be doing in order to deliver the value to our customers and actually to society that we want to deliver. And so we see it as a challenge for us to really move, as it is in our history, to go from electrification, automation to digitalization and drive new digital services and digital solutions, but also enhance, as we say, the electrical and automation solutions that we used to be selling for a long time. And by that, really drive productivity, flexibility, resilience, and manageability of complexity for the value-added change of our customers. We're obviously basically in the B2B business. We're serving other industrial customers that then want to deliver superior value to their end consumers. If you look at our long-standing history, Siemens was founded in the 1850s in Berlin, actually. Sorry, Beate, but we're still keeping that link between Berlin and Munich as a corporation today. And so he was a truly startup entrepreneur, and he was using electricity for two things, for communication and for automation. So he was inventing the pointer telegraph, making the Morse system much less cumbersome, because you had a telegraph system was actually pointing to the letters and numbers that you were morsing, and by that telecommunication could explode. He was the first one to build a huge telegraph line from St. Petersburg to Calcutta and actually lay the first overseas cable from Europe to the US. So that was startup business in its best in the Industrial Revolution of the 19th century. On the other hand, he was focusing on the electrodynamic principle to really drive electrical engines, so to be able to automate machinery rather than with manual labor or drive it just with steam. From there was a huge growth story over the years and decades until today, and we were driving things in many areas. If you look at beyond all these innovations, for example, at the wind business, in the beginning of 2000s, actually when even Silicon Valley was after the bursting of the first digital bubble, focusing on clean tech, we were going massively into renewable energy. We were buying a small Danish startup company with 200-300 million euro at the time in sales, and we were boosting it in just a decade to a 6 billion leading energy providing production company when we provide wind power today to the globe, being the global leader in offshore wind farms, but also onshore wind technology around the world. So these drives and these growth stories are possible still and necessary to be driven in the core of the electrification business. But then, of course, we already, since the 1960s, somewhere hidden in the middle, with our thematic automation system, we were starting to dominate the global world on automation and factory automation. Today, 30 to 40% of all factories in the world are automated by Siemens automation technology. Automation is a little bit more a hidden technology because you don't see it. It's embedded in the machinery that's running. But that's the intelligence. That's what today is the Internet of Things. It's coordinating thousands of sensors and actually actuators in real time, making sure complex production processes run properly and orderly and flexibly. And on that base and that know-how, we're now putting the digitalization efforts and integrating the progress and the explosion of data. And of course, we also do this with different means. In the past, it was mainly internal R&D. Today, of course, it's more external innovation. It's open innovation. It's cooperation with startups in Berlin, in the Silicon Valley, but also in China. And so we are not only one of the biggest corporate venture investors, so we are inventing and investing in startup companies. We're also starting lots of startup companies ourselves and are being incubators and accelerators for that kind of innovation. So how does it really merge, this real world of electrification and automation with digitalization? Look at this picture, for example, of a control station for the operation of wind turbines. Here, in a team of experts, over 100, are controlling and operating more than 7,000 to 8,000 wind turbines 24/7. So we're making sure that these run properly, and 85% of all alarms that may occur are being dealt with remotely, and so all kinds of mechanisms of remote monitoring, remote maintenance are being applied. With that, we can drive these wind parks not only to proper operation and resilience and uptime, but also optimize their use. For example, if you have a wind park like this in the Baltic Sea, it's not only about the individual turbines, about how this park really works together as an optimal virtual power plant that utilizing the wind power that's coming in an optimal way. And here we obviously have to apply self-learning algorithms that optimize the position of the blades in a way that you can actually increase the efficiency rate of the overall wind farm in the mode of operation by 1 or 2 percentage points. Doesn't sound much, but everybody who knows about energy and the laws of thermodynamics knows that going from an efficiency rate like in normal gas turbines from 60 to 61% is a big deal. And here it's the same thing, because these 1 or 2 percentage points of further efficiency you basically get for free just by applying a big data analytics and these kinds of digital solutions to enhancing electrical systems. Similar things happen, and Michael Mendenhall was mentioning this morning, the manufacturing process itself. Again, we are automating it since the 60s, are really one of the global leaders in this field. So that always has been about productivity, flexibility, resilience, uptime, and increasing improvements. But now the physical manufacturing process becomes 100% a digital twin. So from the point of the inception of the product, which obviously today for complex products like cars, for example, is 100% virtual in the CAD system, in the computer-aided design system, the entire value chain from engineering this car, planning the manufacturing process, engineering the manufacturing process, engineering the virtual prototype, even putting the virtual prototype into a virtual wind channel to optimize its shape and its wind characteristics on the road, and simulating so the product characteristics as well as the manufacturing process. Again, that all happens virtually before the first dollar or euro is spent on iron and steel when you build the actual manufacturing plant. And by that, you can dramatically reduce cost. You can increase time to market by 30%. Michael was talking about 9 months, a product life cycle. Well, cars are not that short in cost life cycles yet, but even there they have come down considerably, and every month earlier drives productivity tremendously. And the idea is really to close the loop. We have always been talking about design to manufacturability, design to quality, design to performance. Now we're closing the loop. We design to manufacturability, we simulate the manufacturing, then we learn what we have to change in the design, change it before, again, we spend the first dollar on iron and steel to actually build the factory. This is the Ghibli, actually, of Maserati. Maserati has developed this car completely virtually at first, down to the last manufacturing step, and with Ghibli now is actually experiencing some explosive growth and has the highest turnover they ever had. On the Hanover Industrial Fair, we also showed something like this. In Germany, usually discussed currently in Europe, or actually in the entire world. In China, you have a conference every second week about it, about Industry 4.0. Industry 4.0 is about much more interactive manufacturing processes, where the actual products know what has to be done for them to be built. And we are using that system, for example, in a showcase plant in Amberg in the Oberpfalz. That's also a very nice place in Bavaria, where actually our Chancellor Merkel has just visited us also a few weeks ago. And where we have really realized that to the fullest extent. Thousands of products in millions of units are being produced here extremely flexibly, with a failure rate nowadays only of 10 per million products that are being produced there. And one key here is the 100% automation and digitalization of the manufacturing process. Each product knows what has to happen to them, and if they go into the manufacturing process, the machinery kind of reacts to each individual product. So that's Industry 4.0 at the forefront. And here you see that we're obviously also cooperating with the world's leading entrepreneurs and leading drivers of thinking on combining the digital and the virtual world. Not only are we closely working with the Infinity Red Bull Racing team, one of the most successful teams in the Formula One in the last years, where again we have created a 100% virtual twin of their car, of their racing machine, to continuously optimize it and change it for the use and the manufacturing process. And this is a picture that you can't probably see, unfortunately. These are actually the hands of Elon Musk. And so he is designing a piece of the SpaceX Falcon 1 rocket, as it was done in the movie Iron Man, as you all may know. And Elon said, well, what they can do in the movie, we can actually do ourselves. So he was combining our Siemens NX CAD system with another interface, and was able by a gesture interface to actually assemble the parts of the Falcon rocket. In total, he's actually also using our digital design systems. And as he claims himself, I mean, he has come down with the cost per rocket vis-a-vis NASA by 60 to 70%. And that's really one of the drivers, is the integrated digital design process. Also, Curiosity, our cute little Mars rover, was a product designed in our digital worlds. We see what happens when the real and the digital world collide. You get to the forefront of things. And so that's also what we will continue to drive. We think we will want to make real what matters. Matters to society, to the globe, for example. In the movie it was mentioned that most of our products actually reduce CO2 emissions drastically once they're being applied and replace existing equipment. So rather have wind turbines or high efficient steam tower, gas-fired power plants rather than dirty coal-based steam power ones, for example. And we will continue to drive and apply digital technologies to enhance the electrification, the automation solutions that we have, and drive digital solutions and services themselves, so that when digital and real worlds collide, they don't collide, they merge and fuse to something better and greater. Thank you.